Okay, in this video we're going to have a quick recap of the knowledge that we're going to need to help us to do the new learning. So here we have the information for lithium, and let's just label these numbers. So the 7 is the mass number, and if you remember, parts of the atom that have significant mass are protons and neutrons. They both have a mass of 1. So this is equal to the number of protons and neutrons. The bottom number is the atomic number, or we often refer to this as the proton number. And this tells me, as the name suggests, the number of protons. But remember, because atoms have no overall charge and protons are positively charged, we must have an equal number of negative electrons. So this is also equal to the number of electrons in an atom. So if I do this for lithium, I can see, based on this information, that I have got 3 protons. Now remember, to work out the neutrons, you do the 7 take away 3, so that's going to be 4 neutrons. And then I will also have 3 electrons, because atoms have to be neutral. Okay, so now we've done the recap, let's have a look at some new learning to help us with the work that I would like you to do today. So here we have our atom, here's our nucleus, and we're going to look at how the electrons that an atom has are arranged around the nucleus. If you remember, electrons are arranged in energy levels, so here's our energy level, and each energy level can only hold a certain number of electrons. The rules for us are that the first energy level can hold 2 electrons, the second energy level can hold 8, and the third energy level can also only hold 8 electrons. The second rule we need to know is that the electrons go into the energy level nearest to the nucleus. So for example, if I'm going to put my first electron in, and I'm going to use a cross to represent an electron, I put my cross here, because that's the first energy level and it's near to the nucleus. What I wouldn't do is put my first electron here, because this electron can get closer to the nucleus and they want to get as close as they can to this nucleus. So using these 2 rules, let's have a look at how this works. If I was to do it for lithium, which we just worked out here has 3 electrons, then what I would do is I would put 2 electrons 1 and 2 into my first energy level. That energy level is now full. My third electron therefore would go here. So this would be lithium, and I would write that as 2 electrons in the first, 1 electron in the second. Let's pick a different element. Let's jump down to sodium. So sodium has 11 electrons. Its atomic number is 11. So it has 11 electrons. And if I'm going to do 11 electrons, let's get a bit of room for it. Get rid of these bits. If I'm going to do 11 electrons, remember the first one holds 2 and then it's full. And then we fill up 1, 2, 3, 4, 5, 6, 7, 8. So I've got 2 in the first and 8 in the second. That adds up to 10. I need to get myself to 11. So I need 1 more electron to go there, and that gives me 2 in the first, 8 in the second, and 1 in the third energy level. So my arrangement is 2, 8, 1. We'll try one more. Let's remove these ones for ourselves. So we've got a bit of space. We'll remove these ones. Okay. Let's do the same for, let's pick on a different element. Let's pick on fluorine. Fluorine has 9 electrons. So if I'm going to do 9 electrons, I do 2 in the first, and then let's count them up. So there's 2, 3, 4, 5, 6, 7, 8, 9. So it's 2 in the first, and then there are 7 in the second. So the arrangement is 2, 7, and that is for fluorine. Just something to be aware of, we can get ourselves up to 20 electrons. We have to know the arrangement for 20 electrons. So to get to 20, we actually need another energy level. So let me just add another energy level. Is that going to, that's going to give me an oval. Let's try and do that a bit better. Ooh. Oh no. There we go. Let's get rid of these ones. And what I'm going to do here is make this a little bit bigger. Let's put this on the outside of this. Okay, there we go. So what if I was going to do, let's say we do calcium. Calcium has got 20 electrons. So I'm going to put 2 in the first, and then it's full. Then I'm going to put 8 in the second, and then it's full. So there's 2 and 8, that's up to 10. I can fill another one with 8. There's that one. And then what I've got 2, this has up to 18, so I need to get 2 more. So I'm going to put 1 and 2. So that is going to be, calcium is 2, 8, 8, 2 for its electron arrangement. Okay, in this part of the video, we're just going to link the electron arrangement to the periodic table. So if you remember, we said the first energy level can hold 2 electrons. Then we said the second energy level can hold 8 electrons. And the third energy level can also hold 8 electrons. If we look at why these numbers are important, so I'm going to go up to the periodic table here. And if we look at the first period, now remember the first period is the first row as you go across the periodic table. And if you look at this first row across the periodic table, we have got 1, 2 elements in this. So there they are. And this first energy level can only hold 2 electrons. So the first period has 2 elements, and therefore there are 2 electrons in the first energy level. If we look at the second period, so let's just put this is our first period. Not happening there, is it? This is our first period. This now is our second period. So if you look at the second period, there are 1, 2, then a jump across 3, 4, 5, 6, 7, 8 elements in the second period. And the second energy level can hold 8 electrons. So you can see there's a link between the number of electrons in an energy level and the number of elements in a period. If we come down to the third period, again remember from our picture earlier, this can hold 8 electrons. Let's count this. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements and there are 8 electrons that can fit into this. So if we ever forget the rules, we can come back to our periodic table and we can see that the rules are going to show us that the first period, the first energy level has 2, the second one can have 8, and the third one can have 8, and there we have our rules for the number of electrons in each energy level. Okay then, so this is the task I'd like you to do. Here are the rules as reminders. So we said that this is the maximum electrons that each energy level can hold, and we've always said that electrons always go into the first energy level, and that's the one nearest to the nucleus. It has to fill up from the nucleus at the beginning, okay? So we're going to do this for the first 20 elements. So the first element in the periodic table is hydrogen. So let's write the element down so we know what we're talking about. The first one is hydrogen. I'm going to do a little dot for a nucleus, and I'm going to use my pen to help me to draw my first energy level. And hydrogen only has 1 electron, so we record that just as 1, and that is how we draw it. If we move across that first period, we go to our next element, which is helium. So let's have helium. Helium has 2 electrons, 1, 2. This is going to be helium, and we'd write that down as an arrangement of 2. We've now done the first period, so we've now come back to the second period, and the first element on the second period is lithium. So to do lithium, we would draw our energy level, okay, and we know that lithium has 3 electrons, so there's 2 in the first, that's then full. So in order to get my third electron in, let's have another one here. We can cheat a little bit with my picture. And I'm going to put my electron there, and I'm going to write that down as 2, 1. 2 in the first, 1 electron in the second energy level, adds up to 3. There is lithium. So what I want you to do now is to do this for the first 20 elements in order. So we go from lithium to beryllium, and then boron and carbon, and so on as you go across. And in each space in your books, you're going to draw one of these diagrams to represent this, and write the arrangement underneath, so we've got a clearly identifiable pattern for the electron arrangement. Okay. When you've done this, and there should be the space there to do 20, what I'd like you to do with this then is look at these two questions. Okay, so go back through your information you've got, and I want to know what is the pattern in group number and the electron arrangement, and what is the pattern between the period the element is in and its electron arrangement. And see in this space if you could jot down 2 rules for those questions.